Good morning.
Good morning,
My
sir.
voice is audible to you?
Yes, sir.
Am I audible to you?
Yes, sir.
Okay. Is it clear now?
Yes, sir.
Thank you. Yeah, very good morning. So when will be our physical classes will start?
21st, sir.
21st. Fine. So what topics were discussed in last class? What the topics were discussed in last class?
So we discussed
Switch.
about switching.
Switching.
We started circuit switching.
Good, good, good. What is the basic purpose of switching? Nice one, Pranit. Pranit, are you there? Pranit. Yes, someone called to Pranit. Okay. Fine. Right. So last class we completed about switching concepts. What is the main purpose of switching means? When we are connecting multiple devices are connected by using different types of topologies. We discussed about what are the disadvantages of topologies. In physical arrangement or physical installation of different types of topologies, we consider about what are different types of installation costs, different types of data loss costs, many things we discussed about that. But to avoid those things, to achieve those limitations, we go to switching concepts. And switching concepts, when it is necessary, we can set up a connection. And when data is available, we can transmit it. Once the data transmission is completed, we can disconnect it. Up to that point, we discussed. And could you please tell me what is the disadvantage of circuit switching? At least someone, at least one or two answers. Disadvantage of circuit switching. Okay, I don't want to waste my time. So in case of circuit switching, we have a three phases. One is setup phase, establish the connection. Second one is data transmission phase. Third one is once all the data is transmitted from one host to another host, you need to discard it. But the problem is, once the connection is established, that connection is dedicated between those two devices only. And at the connection point of time, maybe it is 30 seconds or 40 seconds or 50 seconds. In that particular time band, if no data is available with the source, even though that particular link doesn't dedicated, that doesn't allocated to other combination of pair, due to that, we said that circuit switching is less efficient. Do you understand this point? Up to this point, are we clear? If it is yes, post S in chat box. Those who are following my classes, not songs. Thank you, Shreya. Okay, good. Let's see. Let's go to the next types of packet switching, because we are and these circuit switching techniques in general we use in physical layer. Now we will look into what are different types of other switching techniques we are using in data link layer level, and we are using in network layer level, and we quickly go through what is the delay efficiency and comparison table of different types of switching techniques. My screen is visible to you?
Yes, sir.
So I request all the students, please remember this point, this one. Basically, switching networks are three types: circuit switching networks, packet switching networks, and message switching networks. Yesterday, our last class, we completed the discussion about circuit switching network. Today, we are going to discuss about the two types of packet switching networks, and if time permits, we worked upon message switching networks also, right? So packet switching networks are again dividing into two parts: datagram networks and virtual circuit networks. Now we will look into datagram networks. Right. Basically, what is packet switching? In case of circuit switching, we establish a connection. That connection is dedicated between sender and receiver, and the type of data is transmitted through this transmission medium is bits, because we are implemented in physical layer. Now we move to data link layer or network layer. In this case, they are not bits, they are units. We call it as a frames, or sometimes we call it as a packets. If it is network layer, it is packet. If it is a data link layer, if it is frame. Now let us see how these frames or packets are transmitted by using switching concepts. So a packet switching network divides the data into packets, of course, a fixed or variable size. The size of the packet is determined by the network and the government protocol. For example, if network supports only 1 Mbps, 1 megabyte per second data, then of course your packet size is 1 Mbps. If it is suppose 512 kbps only, then we go with the 512 kbps only. And governing protocol. Protocol means in later on session we will explain what is the protocol, because some protocols does not compatible with data link layer. Some protocols does not compatible with network layer. Why? Because data link layer supports frames, network layer supports packets. The size of the packet is not equal to size of the frame. So in this particular context, there are specific protocols can be implemented in data link layer, and there are some specific protocols can be implemented in network layer also. So depending upon the protocol, we can estimate the size of that particular unit also. So in a packet switching network, there is no resource reservation. Very important point. There is no resource reservation before the transmission of data. Resources are allocated on demand if it is necessary. On demand means source and destination. If source having packets, if source is ready with the packets, then only it requesting switch unreadable connection. If it is not, no packets. If all packets are transmitted, then switch is disabled and assigned to other sender. But this is not happened in the circuit switching network. In case of circuit switching network, if connection is established, even though source having packets ready or packets are not ready, I mean to say bits are ready or bits are not ready, still this is in connection phase. This is the main disadvantage. You understand the main difference between packet switch and circuit switching? Yeah, someone please on your mic and tell me. Do you understand the clear difference between circuit switching and packet switching?
Can you explain it once?
Yeah. Circuit switching means there are three phases. What is first phase? Setup. Setup means establish a connection between sender and receiver. Once the establishment is completed, then this entire channel is dedicated to source and receiver up to completion of the packet transmission, up to completion of the bit transmission. And second is data transmission. Data transmission means we are not sure that the source having continuous data. Maybe this time it is having 10 bits of data in 5 seconds. The total time allocated for this connection is 60 seconds maybe. Up to 60 seconds, this link is dedicated between sender and receiver. First 5 seconds, 10 bits are ready with the sender. It can send it. After 5 seconds, bits are not ready. After 5 seconds, bits are ready. After 5 seconds, bits are not ready. After 10 seconds, bits are ready. After some more 10 seconds, bits are not ready. In this case, when bits are not ready, can we utilize this link? Can we utilize this link, or this link is ideal? Answer please.
It becomes ideal.
Of course, this 10 seconds is ideal, this 5 seconds is ideal, this 5 seconds is ideal. So if you count it, almost up to 20 seconds, this entire dedicated link doesn't allocate to anybody. This is dedicated to this particular device only. If the device is ready with the packets, the device is ready with the bits, then utilize it. If device is not ready with the packets, just keep calm. Don't use that one. But in case of packet switching network, there is no setup phase. There is the connection network. There is a dedicated connection. There is no dedicated connection. The source is there. Destination is there. Here we have a multiple switches: switch 1, switch 2, switch 3, switch 4, and switch 5. All are connected like this. All are connected like this. So this is source point, this is destination point. When source is ready with, for example, 5 packets, then only it requesting switch, please establish a connection. At that time only, it switch is taking the packets. Those 5 packets are received by the switch 1. Once 5 packets is transmitted, if the device is not ready, the switch is disabled, automatically disabled. The switch is allocated to some other device too. Do you understand the clear difference? Here there is setup phase. There is no setup phase. If packets are ready, send it to switch. If packets are not ready, keep calm. That's it. Do you understand this?
Yes, sir.
Right. Let us see. I'll give you some more explanation on this one. So again, packet switching networks are 2 types. One is datagram networks. Second one is virtual circuit networks. We will discuss about datagram switching network. Datagram. In a datagram network, each packet is treated independently of all others. That means if source 1 and source 2. Source 2 having 5 packets. We call it as packet 1, packet 2, packet 3, packet 4, packet 4. Source 2 having other 5 packets. We call it packet 6, packet 7, packet 8, packet 9, packet 10. So if you combine all these 5 packets, it is the actual message of the source 1. If you combine all these packets, it is the actual message of the source 2. But in real time, when these 2 sources are connected to one switch, according to datagram network, it takes packet 1, it takes packet 6. And this particular datagram network doesn't care about whether packet 1 belongs to source 1, whether packet 6 belongs to source 2. For example, next packet is transmitted to same switch. So it contains P1, P6, and P2. So we know that P1, P2 belongs to source 1, but this datagram network doesn't care about whether P1, P2 are related or not. It treats as individual packets or independent packets. Do you understand this point? Do you understand this point? So even if a packet is a part of multi-packet transmission, that means a single message is dividing into multiple packets, same message of the same person, same source. Even though it has the network trace it is there, it has to its existed alone. Alone means packet 1 is different, packet 2 is different, packet 3 also different, packet 4 is different, packet 5 is also different. So these 5 are, even though they belong to same message, it doesn't care. It doesn't know what is it is. Suppose if you have a switch 1 and a switch 2. So when device 1 send a packet from router to this one, when device 1 send a packet to router 1 requesting other switch, other router or other router to router 3. See here switching is a concept, it's not a device. We already explained. Do not confuse. Do not confuse with this one. Router 1, router 2, router 1, router 2, and router 3. Here, router 1 is connected with the source 1 and source 2. Source 1 ready with packet 1, packet 2, and packet 3. And source 2 ready with packet 4, for example, packet 5 and packet 6. Now, this is the concept. Now, packet 1 is sent to router 1. Router 1 requesting router 2, are you busy or free? If router 2 is busy, then at that time, at that particular instant of time, packet 1 go for router 3. Next time, packet 2 is coming. Router 1 doesn't know the because according to datagram networks, it doesn't know if you're following datagram networks. It doesn't know these 3 packets that belong to same source. Again, packet 2 requesting R2. Whether R2 is busy or not. If it is big, now P2 go for this path. That means this direction and this direction both are different. At the receiver side, packet is transmitted this path. Packet 1 is transmitted this path. And receiver receiving this way, either P2 P1 order or P1 to P2 order. We are not sure because P2 transmission rate or P2 links are higher in bandwidth, are very faster than P1 path, then P2 reached first hit. Next P1 reached later. So there is no specific order of packets because of this independent nature. You understand this point?
Yes, sir.
Right. So datagram switching is normally done at the network layer, of course, network layer only. And the switches in a datagram network are traditionally referred as routers. See, switching means on and off. Enable the connection, disable the connection. It's not a device. We treat it as a concept. So the datagram networks are sometimes referred as a connectionless, because there is a setup phase where there is no dedicated link at all existing. It is sharing point only. The term connectionless here means that the packet switch, does not keep information about the connection state because there is no setup phase. That means it doesn't maintain any connection state. If it is available, process it. If it is not available, keep calm. There are no setup or teardown phases. These two are existing in circuit switching networks, not in datagram networks. Each packet is treated the same by a switch regardless of its source and destination. If the path is available, it can go that path. If path is not available, it redirect to other path or other route. Let us see this condition. This is the question. For example, here I want to send a data from A device to X device. A is having 4 packets. These 4 packets belongs to only one device, same device here. But datagram network doesn't care about these 4 are same or not. First, here we have one router 1, and this assume that it is router 2. Assume that this is router 3, and assume that router 4. So when packet 1 is transmitted, packet 1, router 1 check whether router 3 is busy or router 2 is busy. At that point of time, router 2 may be busy. That's why router 1 selecting this path to send packet. Again, packet 2 is ready. Then packet 2 is come to router 1. Again, router 1 checking at that particular second instant of time. At that time, router 2 is free. Now redirect it to this path. And when third is available, it go with this path. Fourth is available, go with this path. So many directions. And at the receiver side, it is not giving guarantee to whatever the order we are sending. It is not equal to the order of receiver. See here, actually we are sending 1, 2, 3, 4, but receiver set is 2, 3, 4. Do you understand datagram networks? Do
Understood.
you understand this? Yeah. This ordering will take care by transport layer. at the fusion called segmentation and reason. This order all contains sequence numbers. These sequence numbers will take care of a transport layer. At the transport level, at the transport layer level, we can reorder the packets and send it to the X in order. That is second case. That is the other concept. But as of now, this is datagram networks. Now, what is efficiency? Now tell me, which one is efficient? Circuit switching networks or packet switching? I mean, datagram networks under packet switching. Which one is efficient?
Datagram.
See, the efficiency of datagram is better than that of circuit switching network because in case of circuit switching, we establish a dedicated connection between source and device up to some particular amount of time. Among that particular amount of time, whether data is ready or not, whether source is ready with the bit stream or not, even though that entire dedicated layer that doesn't allocate to anyone. But in this case, if you see the previous example, in this case, for example, E doesn't have any packets. Then this is not dedicated connection. This is not a setup. There is a setup phase. There is no discord phase. So don't worry. Because I am not spending time for setup. I am not spending time for discord. And at that time, if maybe device B is ready, then it requesting this particular router. Then router sends a message, send your packets. So these packets may be packet 6, packet 7, packet 8. So packets is receiving here. At that time, there is the connection phase. Dynamically, I am asking router 1. Dynamically, I am asking the router 4. Among these two, who are busy or who are free. So according to timer, router 1 is said that I am 60 seconds busy. And router 4 said that I am 10 seconds busy. 10 seconds busy means it will complete early. Then I transmit my P6 by using this path. Right? If it is ready, send it. If it is not ready, don't mind. I don't have any objection. So in this particular context, with respect to this type of scenario, you can tell me which one is efficient as compared to circuit switching network, whether datagram network is efficient or not. See, the efficiency of datagram network is better than that of circuit switching network. Resources are allocated only when there are packets to be transferred. This is very, very important. I hope you understand this point. We already explained many times. Yes, sir.
Yes, sir.
And delay. Now tell me, what is delay here? What is delay? I want to compare this delay with the circuit switching networks and datagram networks. Datagram networks. In case of circuit switching networks, delay for setup and discard. Possible delays for setup the connection and for discard the connection. In case of datagram network, best example is, I will show you this diagram only. This one, A requesting router 1. Dear router 1, I am ready with 4 packets. Could you please take my 4 packets and send it to my destination? It's supposed to be at that particular time, router 1 is busy. Router 1 is busy with other transmission of data. In this case, whether A need to wait or not. Establish whether A source A is need to wait for router 1 or not.
Yes, sir.
Yes. After 10 seconds, router 1 is available and requesting A that, dear A, I am ready now. You can send my packets. Then these 4 packets are received by 1, 2, 3, 4. Again, router 1 searching the path to reach X. Router 1 requesting router 2 this time and router 3 also. Here, maybe router 3 also busy and router 3 is also busy. In this particular time, router 1 need to wait for R2 or R3. Yes, sir.
Yes, sir.
Among these R2 and R3, maybe R2 is available at the time it's sending packet 1. So again, router 2 trying to reach, this time router 4. In this particular time, router 3 is also busy, maybe. Now tell me whether router 2 need to wait for R4 or not. Of course. In this way, these 4 packets facing every point of time, it's need to wait if it is a busy network. Of course, if router 1, 2, 3, 4 all are empty, our delay is very less. So now tell me, delay is depend upon what here? In datagram networks, delay is depend upon when we compare to circuit switching network, here the delay is more or not. Tell me.
It's more, sir.
More. Yes, of course. See, for example, if a number of routers existing between 2 devices are more, automatically here delay is not to set up. Delay is not for TATM. Delay between every 2 pair of devices. Delay in between every 2 pair of devices. That means A to router 1, router 1 to router 2, or router 1 to router 3 for only 1 packet. For second packet also same thing repeated. For third packet also same thing repeated. So that means when packets are increases and the number of intermediate devices are more, delay is very, very complex. You can't even imagine. More delay, more delay. Let us see whether the point is correct or not. Because it is my assumption only. But I believe that it is correct. Let us see. Delay. There may be a greater delay in datagram network than in circuit network. Yes, of course, as of now we discussed the same point. Although there are no setup on TATM base, each packet may experience a wait at a switch before it is forwarded. Because, yes, of course, in addition, since not all packets in a message necessarily travel through the same switches, because they are following their different directions according to their availability, the delay is not uniform for the packets of a message, because we have a 3 directions. For example, if packet will goes this way, packet to this way, packet this way. If this particular path traffic is very low and bandwidth of the channel is very high, so packet will delay is less. But in this path, number of packets are more, network bandwidth is low, then this delay is more. Depend upon the situation, right? Yes, sir. You understand my point?
Yes.
Yes, sir.
Right. So I clearly explained this delay concept because delay is not one part. This is transmission time, propagation time, queuing delay, processing delay. 4 delays are there. I will clearly distinguish those 4 delays in coming classes. See here, transmission time. What is transmission time? Can anybody tell me? Transmission delay or transmission time?
So the time taken to put all the bits of the frame onto the transmission medium.
Perfect, perfect, excellent. So for example, packet contains these many bits. The time required to place all these bits from device to the channel is called transmission time. And anyways, all these data are coming like this 1100111012. At this particular time, the switches take all these packets, and what is the maybe they are performing some time to leave or error correction detection methods. If it is available, check some. Then it will take some time. That is called waiting time. Maybe this particular switch is busy with transmitting other packets. This buffer is not empty. Then this is called waiting time. Once the switch is available, again transmitting. And maybe this is busy, this is waiting time. So when this type of switches increases in between source and destination, automatically delays increasing current. For every switch point of time, I need to wait some time. I need to wait some time. Yes, sir.
Yes, sir.
This is what delay and efficiency of the datagram networks. So as of now, I request you only one point. Do you understand the real difference between circuit switching networks and datagram networks of the packet switching networks? Do you understand this?
Understood.
Yeah, good, good. Now virtual circuit network. Virtual circuit. In case of specific circuit network, we are use a physical path, physical device, physical path. Virtual circuit means here we are not using any physical path. We are not using any physical path. That means sender and receiver. Here we have a router 1 or maybe switch 1, switch 2, switch 3, switch 4, switch 5. We are following many ways, many ways. So how many possible ways here? Source and destination. So in how many ways I can reach from source to destination? What is the limitation of datagram network? What is the limitation of datagram network? For every point of switch, that particular packet is need to wait. Yes or no?
Yes, sir.
Right? So remember that point very carefully. Now I want to avoid that point. I don't want to wait at intermediate switches. I don't want to wait at intermediate switches. Now tell me, to reach from source to destination, how many paths are here? You can tell me. Source to switch 1 to switch 4 to destination. Yes, sir. First path, source to S2 to S4 to destination, or source to S2 to S5 to destination, or source to S3 to S4 to destination, or source to S3 to S5 to destination. Yes, sir. Are you able to understand my point? We have 5 different paths here. Among those 5 paths, we can transmit anyway, any direction. Yes or no?
Yes, sir.
Now, and these connections are not physical paths. These connections are not physical paths. Not physical path. All these are wireless transmission, connectionless services. But in case of datagram networks, even multiple packets. For example, source contains packet 1, packet 2, packet 3. All these 3 packets, we do not have any guarantee that all are following in the same path. May be following, may not be following in datagram networks. But in case of virtual circuit networks, when these 3 packets are available, among these all virtual paths, I take only one path and fix it by using virtual circuit identifier. Virtual circuit identifier means address of the switches, predefined addresses of devices and switches. If I fix this particular path, then switch 1, switch 4 are dedicated to this source and this destination only. When packets are available, it is dedicated to these 2 points only. In this particular case, whether switch 1 is busy for other transmission, do you understand point? Do you understand this? Among these multiple paths, I am selecting one path as my fixed path, but I am not set up anything. I'm not just by using virtual circuit identifier concept. I will explain this in the next coming topic. In this case, I take switch 1 only, I take switch 4. All these 3 packets need to transmit it through switch 1, through switch 4. Once the 3 packets are completed, then only we release this one and allocate it switch 1, switch 4 to some other combinations. Let us see. I'll explain what is this exactly. So a virtual circuit network is a cross between circuit switching network and datagram network. That means here we are using connectionless services, but by default we are saving the state of intermediate switches. As in a circuit switching network, there is setup and tear down phase in addition to the data transfer phase, of course. The resources can be allocated during the setup phase as a circuit switching network or on demand as a datagram network. We can go with this feature
Or you can also go with this feature also in virtual circuit concepts. As in a datagram network, data are packetized and each packet carries an address in the header, of course. As in a circuit switching network, all packets follow the same path established within the connection. But how will it happen? A virtual circuit network is normally implemented in the data link layer, while a circuit switching network is implemented in the physical layer, and a datagram is implemented in the network layer. Now, as of now, we completed the explanation about network layer packet switching implementation and circuit switching implementation physical layer. Now we will see how can we implement this virtual circuit networking concept, switching concepts in data link layer. See. The data transmission in the virtual circuit network is like circuit switching network in 3 phases: connection setup, data transfer, connection release. 3 are same. Connection setup, in the setup phase, a switch creates an entry for virtual circuit. That means here I am not creating any physical path. I am not using any physical path, but when source is connected to switch, then switch creates a virtual circuit identifier of the source. That means by using this identifier, switch can recognize it is most priority. And setup request. A setup request frame is sent from the source to the destination. Setup acknowledgement. A special frame called the acknowledgement frame completes the entries in the switching tables. In this phase, source A, after sending all frames to B, sends a special frame called tear down request. Destination B responds with a tear down confirmation frame. All switch delete the. So let us see, because theoretically maybe you are not getting point. Let's see here. What is setup request? First, a sample frame is here. A sample frame. So incoming port virtual circuit identifier 40. Virtual circuit identifier port. Outgoing means this A is connected to switch 1 and the switch 1 is connected to switch 2. Switch 1 is connected to switch 2. So now virtual circuit identifier, it is empty now. Now outgoing, this port is 1 and this virtual circuit identifier 66 now. And this is also empty. And this frame, this one, it is also empty. As of now, all are empty. Now what is acknowledgement? So frame is transmitted like this way. And reaching B. So what is the 77? What is the 77? This is a unique virtual circuit identifier of device B. Device B. So when a setup request is established between A and B, if you observe this, all these are empty. All these are virtual circuit identifier for outgoing is empty. Because I am not sure, first I am requesting to fill these films. I am requesting whether you are free or not, Now, virtual circuit B, if B is readily available, then it sends its virtual circuit identifier to switch 3. Then it is filled with 77. See here, it is empty now. A reversing acknowledgement B is available 77. Now reverse acknowledgement when switch 3 sending the virtual circuit identifier of this incoming packet 22, it is filled here 22. In reverse fashion, this 66 is saving this one. Now there is a dedicated path existing between A to switch 1 to switch 2 to switch 3 to B. So B identifier, it is not connection oriented. B virtual circuit identifier 77 is available with S3. S3 know who is B. And the virtual circuit identifier of S3 is how much? 22. That is available with switch 2. So switch 2 know who is S3 is. In the same way, the switch 2 virtual circuit identifier of 66, it is available with switch 1. In the same way, switch 1 available is 66, it is available with switch 1. So by using these virtual circuit identifiers, I can recognize all my packets transmitted among which switch. Do you understand this concept? Do you understand this?
Yes, sir.
I request all the students, do you understand this? Or just observe the diagram, you can understand it. Just observe carefully. For example, a common question to you, that is, so who are willing to participate? So I want to transmit, I want to send multiple data, or I have a textbook. I have a textbook. I request you to transfer that particular textbook to your friends, a soft copy of textbook to your friends. I need some volunteers. Here we have a 60 students. By using among 60 students, anybody can take up my data and send it to my receiver side. But I don't want duplication. That means among the 60 students, maybe 5 students are interested. I take the phone numbers. Phone number 1, student 1. Phone number 2, student 2. Phone number 3, student 3, and so on. I send my packet of data to phone number 1. And packet 1 sent first among those 60 students. I need to take, that means those 5 students are voluntarily come back to me, sir, we are available. We are free now. Whatever the data you shared to me, we will share the data to my students or other students. So these 5 students are called these virtual circuit identifiers. Right? So my name is KK and destination, some other device. Here we have a student 1 and student 2 and student. So student 3 requesting destination is okay. The destination address given to S3, S3 address is given to S2, S2 address is given to S1, S1 address is given to KK. That address is nothing but virtual circuit identifier. Hope you understand this. Or any doubts?
Understood.
Right. Understood. Good. Now, data transfer. To transfer a frame from a source to destination, all switches need to have a table entry for this virtual circuit. What is this table entry? This is exactly equal to this table. This is the table. This table contains only one virtual circuit identifier. So my data sending, my data receiving. Go with this, the device I'm sending all my packets from switch 1 to switch 2, which contains 22 virtual circuit numbers. So here, virtual circuit number 22 belongs to which device? This device. Okay. That means when I'm sending this packet, I'm reading this virtual circuit identifier. Maybe it is connected to some other switch. That value may be 24, but I'm giving 22 only here. That means I'm sending this way only. If this particular device is busy at the connection phase, I disconnect it, I replace 22 with 24. So by next time, all the packets are transporting this 24. In this way, we can update it. If the contents of table updates, automatically the direction also changes according to requirement. So the table in its simplest form has 4 columns. That means that the switch holds 4 pieces of information for each virtual circuit that is already set up. The data transfer phase is active until the source sends all its frame to the destination. The procedure at the switch is the same for each frame. Of course, same thing. If data is not available, then automatically all those virtual circuit identifiers are disabled. The process creates a virtual circuit, not a real circuit. It is not a physical path between the source and destination. It contains only virtual circuit identifier. That means we all are communicated via a Zoom link with virtual circuit ID. Virtual circuit ID is meeting ID and password. This meeting ID is password is never reported to other combination. For tomorrow's class, this meeting ID is different. This passcode is different. For day after tomorrow class, this meeting code is different. Passcode is different. But if you want to continue a recurrence class for every day, I create only one link, one Zoom link from day 1 to day 60. For all these 60 days, I use the same link. That is called virtual circuit. It contains same meeting code and same passcode. It never changes. But when time changes, when class changes, automatically those will change. That is, we are following different paths there. This is the example. You can take a look of it. Data 14. 14 means when data contains 14, that is device A try to send a packet to the switch which virtual circuit identifier is 14. See, it is 14. Now incoming packet is received by switch 2 and switch 2 sending data to 66. Now 66 available here only. So data is coming here and take 66. Again updating the 66 with 22. That means data going this way, 22. And 22 transmitting here and searching for 77. 77 is B, this one. So according to this VCS, according to virtual circuit identifiers, I can easily identify what are the devices need to send my data, what are the devices need to acknowledge back to this source. So what is delay here? In a virtual circuit network, there is a one-time delay for setup and one-time delay for teardown. If resources are allocated during the setup phase, there is no wait time for individual packets. If resources are allocated during setup, that is, a virtual circuit identifier is available. If switch is available, then only this identifier is storing in the table. Switch is not available. By that time, I need to wait. By that time, I need to wait. When switch is available, then only this virtual circuit identifier storing into that particular table. That information, that particular information is only transmitted to next switch. So the package is traveling through two switches. There are 3 transmission times: the propagation time, data transfer dictated by the scoping lines, a setup delay. Just take this picture and understand this. This one. Same setup and tear down. 3T, setup delay, tear down. What is this 3T? What is this 3 transmission times? That means this place to this place, this one, and this place to this place, and this place to this place. If you are using 2 switches, I need T, 3T. And what is 3-T? For acknowledgement bank. 3T. And setup delay, tear down. That is, it is a combination of virtual circuit and data conversion. It is 2 types. Hope you understood this. Yes, sir.
Yes.
So message switching. So message is nothing but, for example, if link is not sufficient, I'm dividing message into packet 1, packet 2, packet 3. If my link is high bandwidth in nature, that means my message 4 MB. This link size is also 4 Mbps. What is the point of dividing into packets? Take it out. Take entire message at a time. You understood this point? When we are dividing into packets, when the network bandwidth is not sufficient or our protocol is not sufficient, not compatible, at that time, according to protocol standard, I am dividing multiple entire big message into individual packets or frames. But if my network supports, my protocol also supports the high bandwidth nature, then what's the point of dividing into packets? I send all messages at a single stretch, at a single point of time. See here. Message switching was the precursor of the packet switching, where messages were routed in their entirety at a time, one hop at a time. No need of dividing messages into individual chunks. Each message is treated as a separate entity, a single unit. Each message contains addressing information, and at each switch, this information is read and the transfer path to the next switch is decided. Depending on network conditions, a conversation of several messages may not be transferred over the same path. Of course, each message is stored usually on hard drive due to RAM limitations. Because message size is very huge, it is not possible to transmit on time. You need to store somewhere and send it immediately when network is available before being transmitted to the next page. Because of this, it is also known as store and forward. Store and forward, because the time taken to send a message from one device to another device, message is very long. The first part is received to device buffer. Up to receiving of all the messages, I need to wait here. So store, waiting for complete message to store here. Once all the message is available, then only I forward it again. Again, buffer here. This entire message is storing here also. Then only I forward to destination. Compared to packet switching, message switching transmission is somewhat slow because in higher nature. So email is a common application for message switching. A delay in delivering email is allowed, unlike real-time data transfer between two computers. If you observe this one, where we want to upload some 10 images or 25 MB data at that time, still first it is go to outbox. You remember that? Sender. When we are sending a huge mail, that mail contains more data. First, it go to outbox. Outbox means it is acts as a buffer. Buffer means it store all the data, and when network is available, it's sending one by one. Do you observe this point or not? How many of you are familiar with this outbox concept? Outbox. Please let me know what is the difference. Do you understand this point or not? So, delay, since message switching stores each message at intermediate nodes in its entirety, that is, we are storing entire message at a time, being forwarding. Messages experience an end-to-end delay, which is depend on the message length and the number of intermediate nodes, of course. Each additional intermediate node introduces a delay, which is the minimum value. It is the same as packet switching only. This one. See here. Store and forward. For storing and forwarding, we need some delay. And storing entire message, and store here and forward here. Again, store here, forward here. Store here, forward here, like this one. So time delay, this much. Propagation delay and queuing delay. What is queuing delay? Queuing means at the receiver side, if store and forward, the buffer size is maybe 1 GB, but my message size is 2 GB. 2 GB. At that time, it is not sufficient to, even though it is 2 GB, buffer size is 2 GB. But among those 2 GB, 1 GB may be allocated to some other message 3. So up to transmitting of message 3, message 1 is not fit into this 2 GB. Once message is transmitted, this 1 GB is cleared. And again, already 1 GB is available. So again, this message was storing entire 2 GB here. Again, storing, again forward. This is called somewhat delay propagations with respect to message size. So this point and queuing delay and propagation. Propagation means sending and receiving. So this is something about different types of switchings. As of now, most important point is packet switching only, because your syllabus contains this one. Delay, loss, and throughput. Throughput means number of packets transmitted per second. Number of packets transmitted per unit of time. Within second, your network or your device, how many packets are transmitted per second through network is called throughput. So as of now, we deal about delay and loss. So compared to which one is more loss? Circuit switching networks or datagram networks? In circuit switching networks, there is no loss. Data transmitted successfully. But in datagram networks, they are following different paths. If switch 3 is corrupted, the data is lost. And datagram doesn't give any acknowledgement also. Datagram doesn't give any acknowledgement. It is not a reliable service. So loss is more in datagram networks as compared to circuit switching networks. So this is something about your content. We are almost complete everything here. And I already give assignment of internet, network edge, and the service models we already completed, protocol layers and service models. OSI is completed, TCP is our assignment. History of computer network, something like transmission media, LAN, WAN, MAN, all are general concept only. So by end of this week, I already created assignments in Moodle box. Try to write your own ideas and everything and submit as soon as possible. I start evaluating your scripts by end of this week. As of now, any doubts?
No, sir.
Right. So it's already 10:55. Tomorrow we will meet at some other concepts. Tomorrow we will discuss about what are different types of network delays, and we will solve some of the problems on those things. Right. Thank you all.